In the world of software development, our tools usually have one very specific job. But what if I told you that one of the most common protocols we use every single day has been hiding a secret identity? What if a tool we all use for debugging is actually capable of something completely different, and it turns out incredibly useful? I mean, think about it. Your editor, your compiler, your debugger, they all have these really clearly defined roles. But what if one of them has a hidden superpower you've never even noticed? Well, today, we're going to pull off the mask.
And there it is, the big reveal, right up front. The Debug Adapter Protocol, or DAP for short. Yeah, the very thing that connects your editor to your debugger is secretly a perfect engine for running a REPL. Now I know, it's a pretty unconventional idea, but as you're about to see, it works surprisingly well.
So here's our game plan for today. We're going to quickly cover what a REPL actually is, then we'll unmask the protocol itself, see exactly how this clever trick works, and finally, we'll get to the best part, the payoff. Okay, first things first. To really understand the disguise, we need to know what we're even looking for. So what in the world is a REPL? REPL stands for Read, Evaluate, Print Loop. And really, it's just a simple, interactive command line for a programming language. If you've ever popped open a Python or JavaScript console and just started typing commands, well, you've used a REPL. It's like having a direct conversation with a language itself. And this slide just lays out the whole process perfectly. It's a really simple, continuous cycle. The system reads your input, something like 2 plus 2, then it evaluates it to get the answer, 4, it prints that result back to your screen, and then it loops right back around waiting for your next command. Read, eval, print, loop. That's the whole thing. All right, so now we know what a REPL is. Let's meet our hero in disguise, the Debug Adapter Protocol, or DAP. Now, its day job is to be a kind of universal translator for all our debuggers. Its whole official purpose is to be the middleman. See, before DAP, every editor, like VS Code or NeoVim, had to write totally custom code to talk to every single debugger out there, for Python, Java, Go, you name it. It was a mess. DAP created a standard language, so now an editor just has to speak DAP, and the debugger just needs a DAP adapter. Simple. So here's the crucial point. DAP was built for stuff like setting breakpoints, stepping through code, and inspecting variables when a program is paused. It was never, ever intended to be an interactive command line. Using it as a REPL is a complete off-label hack. Okay, this is where it gets really, really cool. How can a protocol designed for one thing be so good at something else entirely? Let's connect the dots. This is the aha moment. What's so wild here is just how perfectly the pieces fit together. Think about it. A REPL needs to do 3 basic things: evaluate some code, show you a simple result, and let you inspect more complex data. Now, look at what DAP gives us: an evaluate command, a result string, and a variables command. It's a perfect one-to-one match. It's almost like it was meant to be. But here's the real secret weapon that makes this whole thing possible, especially for more than just simple numbers. When you evaluate something complex, like an object, the DAP response gives you this little number called a variablesReference. And this number is basically a ticket, an ID for that piece of data. So that begs the question, right? If you just get a number back, how do you actually see what's inside the object or the list that you just evaluated? And here's the simple 2-step dance. First, you send your evaluate request and you get back that variablesReference ticket. Then you cache in that ticket with a new variables request to see what's inside. And the best part? The stuff inside can have its own tickets, letting you drill down into complex data, layer by layer, just like in a real debugger. So we've seen the how, but that leads us to the biggest question of all, the why. I mean, why go through all the trouble of hijacking a debugging protocol when you could just, build a REPL from scratch? Seriously, why bother? It seems like a lot of work for a clever hack. Is there a real practical benefit here, or is it just for fun? And the answer is just refreshingly honest. Clever laziness. The developer who figured this out didn't want to build a whole new user interface for their REPL. Why would they? They already had a fantastic UI for inspecting data. The debugger UI built right into their editor. They were used to it, they had their key maps all set up, and they didn't want to start over. And that is the real win. By piggybacking on DAP, you get a rich, interactive, battle-tested UI for free. This lets a developer focus all their energy on what really matters: the evaluation logic for their language, instead of wasting weeks or months reinventing the wheel on the user interface. So the payoff is huge. But, as you might guess, this trick isn't completely free. Let's talk about the fine print, the necessary baggage you have to carry around when you're wearing this disguise. So, is it truly a plug-and-play solution? Well, not quite. Because you're wearing the debugger disguise, you have to play the part, at least a little bit, to keep the protocol happy. This here is the required boilerplate. To satisfy the DAP spec, you have to handle the initial session setup, you have to respond to these dummy launch requests, politely say no thanks to things you don't support like breakpoints, and then manage the final cleanup. They're mostly just empty functions, but they have to be there for the disguise to actually work.
So what's the big takeaway here? It's a really powerful lesson in creative problem solving and just looking at your tools differently. We've seen how a tool that was designed for one specific job can be brilliantly repurposed for something completely different, all because it happened to have the right pieces. It's a solution that saves a massive amount of time and effort.
And that leaves us with a final thought to chew on. This entire discovery came from looking at a familiar tool from a slightly different angle. So the question is, what other protocols or tools are we all using every single day that might just have their own secret identity, waiting to be discovered?